Hi there, welcome to Tech Days Online, special DDD edition. So we're coming to you from TVP, whilst at the same time, in the building next door to us, the Community Conference Developer Days is running. And that gives us a great opportunity to buttonhole speakers that we haven't managed to get on Tech Days Online previously. So with me is the inestimable Gary Short. Gary, you're a DSA for Microsoft. So should we start by explaining what on earth a DSA is?
Sure. So a DSA is a data solution architect. So what that actually means is I'm responsible for advising Microsoft's customers on all issues with regard to ingestion, storage, and advanced analytics on the Azure platform. And advanced analytics includes things like machine learning and artificial intelligence and that kind of stuff.
Okay. And before you were a DSA at Microsoft, I know for many years you were an MVP, but you weren't an MVP in data solutions, were you?
No, that's right. So there was no data science MVP. So I was an MVP for 10 years. I've been with Microsoft now for a year and a half. Before that, I was an MVP for around 10 years. At that point, there was no MVP award for data science, so I was awarded as a C# MVP because at that point I wrote all my code in C#. So.
And then you joined Microsoft, and they went, "Aha! It's all right, guys. He's gone. We can create."
Actually, it was pretty much as soon as I joined, they went, "What we really need is a data science MVP." Yeah. So that's how that goes, I'm afraid.
I spotted a pattern. So I was going to say because we haven't done them yet, going to do a Grok Talk this lunchtime, and we thought it'd be great if you could come and do that same session for us. So what are you going to talk about today, Mr. Gary Short?
So what I'm going to talk about today in the Grok Talk, which is a 10-minute talk, so obviously we're just going to slow it down a little bit. It'll be faster time when I deliver it. But what I'm going to talk about is Markov, Trump, and counter-radicalization.
Okay.
So I'll advance the slides a little bit. I mean, here's the bit we talked about. As I said, I'm a data solution architect for Microsoft. Data solution architecture covers a broad church, and I actually specialize in predictive analytics, which is the machine learning and the AI side of things, computational linguistics, and machine vision. What we're going to talk about in this particular Grok Talk, it falls into the computational linguistics category. And here's how you can contact me if you've got any questions about what you see or anything like that. Just feel free to ping me a line. So what I'm talking about here is what is counter-radicalization. Now, radicalization sounds really hard, and counter-radicalization therefore must be hard because you're trying to run something that's by that, when it's all about the radicalization of people who are persuaded to have a radical view of their particular religion and then further persuaded to carry out atrocities based on that radical view. Okay. And actually, it sounds terrible and really hard and complicated, but when you scrape all that down, actually it's just persuasion. Okay? It's persuasion of a particular nature, but we do persuasion all the time. Every day you are persuaded to buy a particular brand of beans over another particular brand of beans. Okay. These people are actually persuaded to move from a moderate view of their religion to a more radical view of the religion. So we're talking persuasion, and when we say counter-radicalization, we're really talking about exactly the same thing. We're talking about persuasion, but we're trying to persuade them to go the other way, to move from holding a radical view of their religion actually back to holding a more moderate view of their religion. And actually this is something really hard to do. When you're talking about religion and politics, and actually we're going to for demonstration purposes, we're going to substitute politics for religion because it's slightly less contentious. It's hard then because people tend to be emotionally and psychologically invested in the religion that they hold and the politics they hold. And actually, for a lot of people, religion and politics go hand in hand. Okay. So it's difficult to actually challenge that investment, that worldview that they've had. And there's two main reasons. Actually, there's a lot of psychological reasons, but there's two we're going to cover because we're limited time here. One of them is cognitive dissonance. And cognitive dissonance is when you are faced with a particular piece of evidence that runs counter to your worldview. In computer technical terms, if we say there's a high compute load in changing your worldview, it's computationally expensive to change your worldview. It's much easier to change the evidence so that it fits with your worldview.
Right.
And actually, there's a good reason for this. In 21st century modern times, you think, well, that's a really bad thing. We should move away from that. But actually, there's a really good evolutionary reason for why we have cognitive dissonance. If you imagine Lewis and Clark, for example, setting off across America, right, and then after the first 400 miles going, sod it. There's nothing here. There's so much evidence that shows there's absolutely nothing here. Let's go back. No, they had cognitive dissonance. They see my worldview is there's another side of America over there. We need to go and find that. And all the evidence that they were seeing ran counter to that worldview. So they just changed what the evidence was and counter. So there's a good evolutionary reason for having that. But so here's an example of cognitive dissonance. I'm quite vocal, shall we say, in the whole.
No, really, yeah. I never would have tweeted.
I am quite vocal in the whole kind of Scottish independence political thing. So here's something that somebody posted on my Twitter feed. And what they're saying here is they say vote Tory. Urged newspapers owned by billionaire tax avoiders. So what they're trying to say, their worldview is that actually the whole kind of political, the kind of a political commercial massignation is going on there, and newspaper editors are urging people to vote Conservative because actually the Conservatives will give them an easy ride on tax and things like that. And that's the worldview that this person holds, and here's some evidence to support that. Okay. I say, well, that's fine, but let me show me some evidence that challenges that. So I say, well, this is awkward because actually that was Rupert Murdoch you showed there, and here's Rupert Murdoch's son in Scotland, and actually he's not supporting the Tories in Scotland, he's actually supporting the SNP. So really, is it possible that these people are not actually political animals at all? What they've actually done is, the polls tell them in Scotland the SNP are more popular, so they're appealing to the broader market in Scotland, and in England and Wales, the polls tell them the Tories were more popular. Turns out, that wasn't quite right, but it's what the polls were telling them. So actually, is it possible that these people who are trying to sell something are actually just trying to appeal to a broader market?
Reflect popular opinion to sell papers. Yeah, okay.
Now, that evidence is irrefutable. You can't challenge the evidence because it's the front page of the Sun. You can go and check, right? So you can't argue the evidence. So cognitive dissonance says you have to change the evidence now to fit your worldview. And as an SNP and a Scottish independence supporter, his worldview is that independence is a good idea. Okay. So can he change this evidence to fit with his worldview? And in fact, he can, because he then said, well, perhaps these billionaires can see something in Scotland being independent now, something that's a good thing. So he's changed the evidence now to still fit within his worldview. So the investment that he's made in that belief is still actually supported by the evidence that I'm showing. Yeah. And that's cognitive dissonance. The other one that makes persuading people in religion and in politics really difficult is a thing called the backfire effect. Now, if I say to you, why did you vote a particular way, right? You'll say, oh, it's because such and such, right? And you'll give one reason. Actually, nobody just has one reason for supporting a religion or a political party, right? They're going to have a slew of reasons. But when you ask them that question, what they're going to give you is the belief that they hold either most strongly or they feel most comfortable defending in the given situation that they find themselves in. Okay? And the backfire effect is where you take that one thing that they've told them and you provide them with incontrovertible evidence that what they believe is wrong. Okay? Well, they don't have to use cognitive dissonance, because cognitive dissonance is kind of used when it's just the one piece of evidence. They already have 10 other reasons why they believe. So they're willing to give that one up, right? Because they've got 10 more. So they don't feel the need to change that. They just go, well, that's okay. So psychologically, they say, that's okay, because I've got these 9 other reasons. The backfire effect means that not only will they fall back on those 9 reasons, but those 9 reasons now become stronger. So if somebody has 10 reasons for believing a thing, and they have 1 really strong belief and 9 weak beliefs, and you take that strong belief away, what you can find is you've now got 9 strong beliefs, because they fall back. And that's why it's called the backfire effect, because what you were trying to do was persuade them to go one way, and what you've actually done is entrench their view in the other way. Right. And that's why it's called the backfire effect. And that kind of looks like this. Here's somebody posted on my Twitter to say that kind of the Tories promised that there'll be 350 million that was going to Europe put into the NHS, and that was on the bus, and they lied, never trust a Tory. Well, I said, well, that's not strictly true, because it wasn't a Tory policy. That was the Leave campaign, and Leave campaign had a broad support across, broad support across parties, including actually the SNP, which is the party that you support. So actually, the party that you support had people supporting this particular view. Right. So there's that. So that's challenged, and that particular viewpoint is now gone. So if we move over, she said, yes, but it was only Boris Johnson in the bus. Right? Like you would have a bus driving around with just one person. She was saying, well, the SNP people that I know, they might have supported that, but they were never in the bus campaigning for that and that kind of thing. It was only ever Boris that was in the bus. And I said, but it doesn't really matter who was there. I'm willing to assume for the sake of argument that you're right. It was only Boris in that bus. It was still backed by members of your political party. 350 million for the NHS was still backed by your political party. Right? Well, she comes back with, well, that's right. I would have backed that too. That's a really good, that amount of money in for the NHS. That is a really good deal, so I would have backed that as well. So actually, people supporting that from my party went wrong because it was a good deal, but actually it was only the Tories that lied afterwards, right? Because nobody else lied afterwards when they didn't actually deliver it. Now, the fact that it was only the Tories, because they were in government, it was only the Tories who could deliver it. I'm not sure it would have been any different if it had been Labour or Liberals or anybody else who'd been in power. I still don't think the day after the Brexit vote there would have been 350 million available for the NHS. Yeah. However, so but she still wants this, she holds this world belief that Tories are liars, and what we've actually done is, although we've proven one thing, which is that it was a Tory policy, we've proven that it wasn't a Tory policy, it had broad supporting, well, it was fine, she's fallen back on the other beliefs to support that other evidence.
That says, the Tories must have misled the people I believe in to believe them.
Exactly. So yeah. and again, we've backfired there. All we've really done is made our beliefs in other things stronger. So, how do we actually achieve this level of persuasion in this one? I mean, there's lots and lots of ways to do it. This is just an example of one way to do it. So how we do it is we have a pipeline, and this is what we do. What we do is we capture texts that we know is effective in counter-radicalization, and we just mean persuasion, moving people from a radical view to a moderate view. Right. How do we get to this text? Well, we can get it from focus groups, from known good text. We can search for Twitter, and where we see individuals actually accepting arguments and becoming more moderate in their posts. We can actually have a look at those posts that led them that way and say, yes, this works. Let's keep this kind of thing.
So you're doing that as a human step. You as a person are looking at that and going, okay, well, I'm reading that text and I believe this is appropriate for what I'm trying to achieve. You're not doing this by any sort of machine learning or electronic method.
No, and even if we did do it by machine learning and electronics, that machine learning would have to be trained. This is absolutely a supervised, it is a supervised task. Yep. Now, it can either be done by a human or it can be done by a trained piece of machine learning or AI, but that still needs to be trained.
Yes,
so whichever way
you
look at it,
however you're going to do it, because you can't train it to find it unless you found the stuff in the first place.
Correct. So it's a human thing at some point. And then once we've got that, what we do is we use a bit of artificial intelligence, a bit of statistical artificial intelligence, to generate text which is statistically like the captured text. Okay. So you have a massive corpus of text, and what we do is we analyze that text, and that text is going to have a statistical footprint for the one, or a statistical fingerprint for the want of a better word. And what we want to do is we want to generate text which has the same statistical footprint. Okay. And how we do that is with a Markov chain, right? So here's a kind of definition of how we use it here. So a Markov chain, what we do is, given n words to start off with, we return the next w words which have the highest probability of following if it were in that text. Now, that's kind of abstract and high level and what? So here's a much simpler example. If I flick a coin and ask you to call heads or tails, what's the probability that you'll get it right?
50-50.
Okay. Because we're in a Markov chain, remember the Markov chain says what, so we're in a chain, okay? So if the 200 previous links in the chain all come back heads, and I flick a coin now and I say heads or tails, what's the probability of you getting it correct if you call tails, say?
So I'm hoping it's not your two-headed or two-tailed coin, and it should still be 50-50.
Exactly, it is a fair coin, and it is still 50-50 because it's a Markov chain. Markov chain says the next step in the chain is a probabilistic function of where I am now, and nothing else. Right. So when I flick the coin, it's only to do with what happened here. Okay? The fact that the previous 200 links in the chain were all heads has no bearing on what's going to happen now. Okay?
So we're looking forward, we're never looking at what's happened
before. You may end up going back because the path may lead you back, but actually what it means is the next step in the chain from here, everything that I need to decide where to go, I've got right now. I don't need to refer backwards to anything in order to run the probabilistic function that takes me to the next step. Okay. And then from there I can go on and on and on. And you may end up looping back, and there's absolutely nothing wrong with that because that means that's what happens statistically, and that is fine. But you didn't need any of that information in order to go forward. And that's all that means. And then once we can do that, once we can actually generate text that has the same statistical footprint as what we have in the corpus of text, then of course we can completely automate that. And now we can create as many social media bots as we need, forum posting bots, Facebook page bots, however many we need, right? And we can post out this continual message 24 hours a day, 7 days a year, 7 days a year, 7 days a week, 365 days a year. We can continually post this persuasive message that will move people from having a radical view of the religion to a more moderate view of their religion.
I often wondered how you tweet so much. Now I know.
That's what it is. It's a Markov
bot. A Gary bot.
It's a Gary bot. There's a scary thought.
Let's have a look at the code that you've written to do this, Gary, then.
Sure.
What have you got on screen now?
So what I've got here is the code to do it. And in a minute, I'll talk you through the code. But I think the easiest thing to do is kind of show you what is generated from that, first of all. Now, what you have to bear in mind is that I've got a very small corpus, because it was just a few of the speeches that he gave before he became president. And we haven't tweaked the model in any way. We haven't extended the corpus to give us more details. So what you'll find generated is text that maybe doesn't make 100% sense. You read it and you went, well, that's just... it doesn't really make a lot of sense, but you get the idea that, yeah, that's a view that Trump has or something that Trump would say. So let's just quickly have a look at that. So we can hit this now. And we can pop it up there. So if we just read some of those out at random, so if we look at that one that says, they say we can't believe what we're getting away with murder. This broadcast just this little while ago before I came in here because I wanted to see exactly where we were before I started speaking. I was amazed at the kind of numbers that we're getting in terms of the extra people coming in. That totally sounds like the way that Trump was speaking before the presidency. Yeah. Now, it doesn't make a lot of sense because the corpus that we've got to build on is really small. Right. But actually, when you read that, you think, I get the idea of what they're saying there. It's basically saying, I'm really popular, and when you read the press are against me. They're saying I don't have any numbers, but actually, I was amazed when I saw how many people had turned up. That totally sounds like the kind of thing that Trump was saying in the run-up to the election. But that text there is completely generated just to statistically look like that text. That text doesn't appear anywhere in the corpus that we actually have.
Okay. So how are you generating that?
So
I assume you've got to start somewhere and then you build the sentence.
Absolutely. So let's jump into the code now and have a look. Actually, so here if we look in the main function, we're only actually doing two things, right? What we're actually doing is we're creating a model. So we take the corpus of text and we create this Markov model from the text.
Okay.
And then we get it to Trump like tweet like Trump. Using that model that we've generated.
Okay, right.
We should totally keep that in. That's fun. That's actually the best joke I'll probably tell today.
Can you remember to tell it again in the Grok talk in an hour's time?
Probably not, no. So if we go along and we just have a look to see, well, how do we create this model in the first place? So if I just jump down into that actual method, what we do here is we take the entire corpus, right, and we break it down into sentences for a start. And actually, if we then just drill down into there a little bit, actually you can see there's an extremely naive method of doing that. What I actually do is I just take the tweets and then I use this regular expression for finding sentence ends, right? Okay. And then what that will do, the regular expression will then return me a whole bunch of things which match that, and because that matches the sentence ends, what I'm getting is a whole bunch of sentences. Now this is really naive, and it will fall down on things like Mrs. and Mr. because it thinks it's a sentence end. But it's really naive. But for demonstrational purposes, it works perfectly, and of course we can tweak that going forward. So if we jump back to where we were, once we've got those sentences, what we do is for every sentence in the group we've got, we loop through, and I'll let people read the code for itself. But what we're actually doing is we're taking a 2-word window. Okay? So we take a window of 2 words, and then we take that, and that becomes the key into our dictionary. And then from that point on, we take the rest of the sentence, and that becomes the value in a dictionary. Right? So we actually have a list of values, and we add that to the list of values. Okay?
Is there a specific reason why I can appreciate why not 1 word, because that makes no sense at all. But why 2? Why not 3 or 4?
Because experimentation shows us that's right. If you use 1 word, then you just get absolute nonsense. Yeah. If you use any more than 2 words, what you get is copies of great passages out of the corpus. So it's like you're just copying it. And we've found by experimentation that 2 gives us that perfect blend of making sense but not copying great swathes of the passage.
Okay.
So once we've done that, so we have that two-word window. We take the rest of the sentence and we add it to the list of things in the values, and then we advance that window one word, right? And we repeat until we get to the end, not to the end of the sentence, but the fact that the two-word window there, there's no value, right? And then we get the next sentence, and we just keep doing that. So we've basically got, and then what will happen is the next time round we'll take that the two words. We'll say, is this in here already? Yes, it is. Excellent. Take the remainder of the sentence and add that to the list. And what you get then is the phrases that you use in your speech will kind of form a kind of natural bell curve, probably, but not necessarily. But there'll be some kind of probabilistic distribution of how you speak and how you write. Right. You'll find that because we're transferring that exactly into the list of values that's associated with that key, then what we're actually doing is matching exactly that distribution. Okay? So that's important. So we're basically, it's just a way of encoding that probabilistic distribution. So then when we go back up here, so once we've built our model, up here, all we need to do then is to use that model and then tweet like Trump. So again, if we go in to see how we do that, here what we do is, when we're starting the chain, we don't have a starting point. We said in the Markov chain, the next link in the chain is a probabilistic function of where we are right now. Right. Well, when we start, we're not anywhere. Okay, so it's random probability then. So what we do is we just randomly pick a key out of there, and then we say with this key there'll be a probabilistic distribution attached to that. I'm going to then randomly index into that distribution and pick out the value at that point. And then we start. Okay. And then what we do is we then take the last two words of the sentence, because Markov says it's a function of where we are, and where we are is this sentence. Okay. So we then take the last two words out of that sentence we've generated, and then we find that in our index, and then again we then randomly index into the probabilistic distribution to get the text. And we just keep going. And at some point we say, right, because we're tweeting, we say, right, have we reached the maximum amount of characters, or have we exceeded that? And if we've exceeded it, we march back a bit, and if we haven't, then we add it until we have. And then when we get to roughly 140 characters, we cut it off. And that is all there is to it, really. So if we go back to the slides now, if people want to play with that themselves, then they can the corpus from the speeches and the code itself, you can find it at my GitHub repository, which you should be able to see on the screen now. Okay. And that's pretty much how that works.
I definitely think it sounds like you use one of those just from day to day to tweet. So what are the applications of that kind of stuff? I mean, can you wire that in to respond to certain tweets, things like that? So if I tweeted a certain sentence, you could have something that was listening to it, picking up parts of that sentence and using it to go into your index of data to then trigger the response.
Right. So no, because it would be, you would say something, right? Okay, and I would pick up on that, and then what I would do is I would randomly index into the probabilistic distribution and pull out a value. That value might have no bearing on what you said. Right. So very quickly it would become obvious that I wasn't really in a conversation and I was just tweeting at you.
So this isn't a technology that can be used to counter something I put out. It's more just to continuously broadcast positive feeling, if you like. Yeah.
Absolutely. So to actually do that, there is absolutely ways of solving the problem that you just presented there, and maybe in another presentation we can cover that, but we don't have time to cover it here. But you can absolutely, I absolutely know how to do that. You can do that with a thing called a generative adversarial neural network, right? And we don't have time to talk about what that is. People at home should go look that up because they're really cool. But that's how you would solve that problem. Here, what we're doing is we're just, if for example, people say, look, this particular forum here is being flooded with messages which are radicalizing people. We can actually have as many of these bots as we want, and we can flood that forum then with messages that we know are proven to actually persuade people to move from a radical view to a more moderate view. So basically what we can do here is we can use this as a tool to drown out radicalization.
Okay, that makes sense. All right. Well, we've just got a couple of minutes left.
Sure.
What I wanted to ask you just before we close, I mentioned that DDD is going on next door.
It is.
I know that you've for quite a long time been engaged and involved in supporting DDD. Can you tell me why you think DDD in particular and events like it are important for the community in general, and why we should support them?
Sure. So I'll answer the first question first, which is why it's important. It is important because these events are free to attend. Okay, so what it basically is professional development, free. So if you can imagine, if you had to pay to have some of the best speakers in the UK come and educate you on the topics that they are passionate and very knowledgeable about, 8 sessions you can go to during the day. If you had to pay for that at a conference this close to London, how expensive that would be. And because it's all voluntary, that's professional development for free. So it is vitally important to the industry. Why I support it actually not because it's a great idea for the reasons I've just said. I don't actually support it for that reason, although it's a great reason. I'm very selfish for my reasons for supporting it, and that is because that's where DDD, that's where I got my start. I did some 10, 11 years ago, whatever, did my first talk at a DDD event here in Reading. And from learning how to be a speaker, and then got a job with DevExpress as a technical evangelist, from where I got into data science, from where I finally, with a few other jobs, ended up working here at Microsoft. And actually you can trace that success all the way back to actually starting speaking at DDD. So given the opportunity, I always like to support DDDs. I will submit talks when I remember, and if you're an organizer of DDD, a regional DDD event, and I haven't submitted to you, it's because I've forgotten, so please ping me a tweet or an email and say, hey, you forgot. I will always submit. I don't always get in. So here, for example, I don't have a main session. I didn't get voted in, but I'm doing this as a lightning talk because I still like to support it. So it's not like I get in every time, but I always submit a paper to everyone because I feel it's good to support because it's where I got my start.
Okay. So just to reinforce that before we close, Gary put it so succinctly.
Easy for you to say.
Back in.
Yes.
If you are working in our industry, these are great events to attend because you'll learn loads of interesting stuff from great people. But if you want to do like Gary and I do and be a speaker and give something back to the community, the key thing we always say about DDD is you don't have to have a proven track record. Submit a session, the audience votes for what they want to watch. And the Grok talks that Gary and I are doing, there's no barrier at all of entry. You just rock up on the day and say, hello, I'd like to do a Grok talk for 10 minutes, please.
Absolutely.
And frankly, I'll quite happily bump him from the session to give you a first-time speaker a slot.
For sure. I mean, as I said, first time I ever spoke was here, so I had no track record whatsoever, and a lot of my technical career I owe to that, so I'll always support it.
Okay. So, Gary, thanks very much for your time.
No problem.
Thanks for taking a few minutes out before the Grok talk. Best of luck with that.
Well, you let me rehearse my talk, which is cool. So I get to rehearse my talk for nothing. So now I'm free to socialise.
And a quick thank you to Martin Beebe, who's been running around. As you probably noticed, the lights keep going on and off here, and every time they go off, Martin has to do a quick sprint circuit around the DX offices to get the sensors to light us back up.
We should be charging him. This is like CrossFit. He'd be paying good money for this at a gym.
Absolutely. You know? Yeah, he's getting slimmer because of us.
Exactly.
All right. So thank you very much. Pay attention to Channel 9. We're going to do a whole bunch more sessions talking to DDD speakers even while we're here today. And look up your local DDD. They're not just in the UK. I know there are some in Australia. I think there are some in the States. And find out when they are. Get involved. And frankly, if there isn't one near you, organise one. Thanks very much.